have different ways that we can classify triangles. We have by sides, which is the most common, which we were just kind of talking about. Equilateral has 3 congruent sides. That's why they have one little dash on each side. An isosceles triangle has 2 congruent sides. So it has 2 little dashes. These ones should be the most familiar in your brains. Like, oh, I've heard of these before. A scalene triangle you should have talked about, but you may not remember it because it's Akko Taco. It has no congruent sides. That's why one side has 1 dash, another side has 2 dashes, and the third side has 3 dashes. They're not congruent at all. You can also classify triangles by angles. The most common one is a right triangle. It has to have a 90-degree angle. An obtuse triangle has an angle that is larger than 90. An acute triangle has 3 small angles. And this one is completely new, and the word is weird, and you're going to be like, she's just making up words at this point. It's called equiangular. It is an equilateral triangle. So when you have an equilateral triangle, it is also equiangular, meaning that all the angles inside are equal to each other. This only works for a 60, 60, 60 triangle because it has to add to make 180, okay? So what we're going to do is we're going to look at this crazy picture, and we need to decide, we're going to classify each triangle by its angles and by its sides. We're going to use sides first because it's easier that way, and then we'll talk about angles. So we need to add in some pictures. We need to add in some information. It says PR bisects SRT. Bisects means it cuts something in half. So let's add this to our picture. If I find segment PR, PR goes all the way through. It's bisecting angle SRT. Notice on above next to the R, it says 30. Where else can I put a 30 if it's an angle bisector? SRT is this whole thing. PR bisects it. 30 is above. Where else can I put 30? Not by the P. Actually, yeah, by the P. You can put 30 over here. You can also put 30 below your angle over here. Because these are equal angles, this is 30, this is 30, meaning this whole angle would be 60. It's cutting it in half. You can also put 30 over here because it's technically alternate interior angles. So yes, that's correct. The next part we need to add is U. It says U is the midpoint of RT. So U and RT are right here. RT is this whole segment. U is right here. If 8 is to the right, where else can I put 8 on this picture? On the other side. So I'm going to add a little dash, and I'm going to put 8 meters here. Does anybody see one more place that I could put 8 meters? On the top, right here. Because it has one little dash. So since this one has a dash, this one has a dash, this one has a dash, that means all of those single dashes are 8 meters. So I'm going to look at the first triangle that they tell me. The first triangle says UQR. So UQR is right here, UQR. I need to decide, is this an equilateral triangle? Is it an isosceles triangle? Or is it a scalene triangle? If there's 2 congruent sides, we have 8, and we have an unknown, obviously longer side. So what type of triangle would that be? Isosceles, perfect. So that's using the sides. Now we're also going to use the angles. So if this is 8 and this is 8, since it's an isosceles triangle, I need to decide, is it an acute triangle? All the angles are smaller than 90. Equiangular to where all the angles are congruent, a right triangle where it has one right angle, or an obtuse triangle where it has one obtuse angle. So what type of angles does that have? It has one acute and it has one obtuse. So this is an obtuse triangle. Isosceles. It's on your paper at the top. It means two congruent sides. Okay, now let's look at the next triangle. It says RST. So RST is this large triangle. RST. What kind of triangle would that be using the sides? Is it isosceles, scalene, or equilateral? Equilateral, perfect. Because every side is 16. This is 16, this is 8 and 8, which is 16, 8 and 8, which is 16. If it's an equilateral triangle, it is also automatically equal angular. You get to 80, it's full credit. 90 and 100 is extra credit. Yeah. Okay, next one is SRQ. So if I look from SR to Q, I don't have any dashes. I know this side is 8. I know this side is 16. I don't know the length of the side, but I do not have any congruency symbols. I don't have any little dashes. So is this isosceles, equilateral, or scalene? Scalene, perfect. There's no congruent sides. And then I have 30, 60, and the square. So what kind of triangle based on angles is that? Right, perfect. Next triangle is PRT. So take a second, find P, find R, and find T. PRT is this bottom triangle. It's like the whole bottom half of the picture. What kind of triangle do we think this is based on its side lengths? Not scalene, isosceles. Because this side is 16, we don't know this long piece, but we know this is 8 and this is 8. So this whole length over here is also 16. So it is isosceles. And then based on the angles, we know this angle is 30. We know this angle is 30. What do you think this whole bottom angle would be in total? Not 60 in total, 120, because this is 60. This would also be 60. So if that angle is 120 degrees, would this triangle be an acute triangle, an equilateral triangle, or an equal angular, sorry, a right or an obtuse? Obtuse, because I have one obtuse angle. I have that 120. Take a second and try the last two. Okay, let's talk about TQU. So if I look at TQU, it's that little baby cute look triangle one. What kind of triangle is that? Equilateral. And if it's equilateral, it's automatically going to be equal angular. The last one is PTQ, which is, or PQT, I said backwards. PQT is right here. We have 30, we have 60. We don't know this angle. What kind of triangle would this be if there's no dashes? Scalene. And then what type of triangle it is based on angle measures? Right. Because This angle is not there. You can either use math. They have to add to make 180. So that would automatically make this 90. Or you can think vertical angles. This is 90. So this is automatically 90 because vertical angles. Yes, it's best. Okay, so now what we're going to do is we're going to be given the sides based on the vertices. This is how it's going to be on your midterm. And you need to determine the lengths and determine what kind of triangle it is based on the side lengths. So we're going to use the distance formula. That's why on your desk, you should hopefully have one of these blue sheets. This is what you're going to be given on the midterm for your formulas. Distance formula is right here next to midpoint. It's right on the front. We are taking our x's, we're going to subtract them. We're going to take the y's, we're going to subtract them, and just simplify our formula. So using our eyeballs, because we can see things like that. What side, can anybody tell me what side is automatically going to be the longest side? Because our eyes are not trying to trick us. It is a graph. AC is going to be the longest. So basically, it's definitely not equilateral because we have a graph, so that's nice. We really only have to find two sides to determine, is it isosceles or is it going to be scalene? Because they're kind of close. We don't know if it's exactly. So let's use the distance formula. We're going to find the distance of, we'll do AB first, and then we'll also do BC as well. So if I'm using A and B, can anybody tell me the coordinate point? I know the graph's kind of ugly. What would be the coordinate point for A? -6 and -2. So this is A. What's B's coordinate? -3 and 5. So we're going to use these two coordinates, find the length, and then we're going to compare it to the other side length because we know AC is obviously going to be the longest. We can see that. So using my distance formula, which is on your blue sheet, it's also on your paper right here. I'm going to take my x's and I'm going to subtract them, take my y's, take them, subtract them. So I'm taking x2, which is -3, and I'm minusing x1, which is -6. So I have -3 minus -6. When you subtract a negative, they come together to make a plus sign. The 6 is not negative anymore. It becomes positive because they make that plus sign to the power of 2. And then I'm going to add. And I'm going to do the same thing with the y's. Y2, which is 5. I'm minusing y1, which is -2. When I'm minusing a negative, it's going to add them. And now I'm going to simplify. I'm going to combine steps at this point, just because I don't want to show literally every single step. What is -3 plus 6? 3. And what is 3 to the power of 2? 9. 5 plus 2 is 7. 7 to the power of 2 is 49. If I add them together, 9 plus 49 is 58. And you will need a calculator to take the square root of this. You cannot use your phones on the test. You can't use your phones, obviously, on the EOC. So your square root button is at the top. Can you stop, Isaiah? Be quiet. Yes, I can. So I'm taking 58 and I'm shifting and square rooting. So shift, and then your square root button is the x squared button. So whoop. So you should get a decimal anytime you take a square root. Realistically, it's very rare. It's going to come out to be a nice number. So I'm going to say 7.6. So we found AB 7.6. We need to compare that length to the other side that we think it might be equal to make sure it's like either the same or not the same. So now I'm going to do BC because I know AC is not going to work. So B, once again, B's coordinate point is -3, 5. C is at 4, 2. And I'm gonna do the same thing. And it doesn't really matter. People are like, which one's first? Which one's second? It literally does not matter. Okay. If the first one's first or the second one's first, it does not matter. As long as you're doing your x's together and you're doing your y's together, it does not matter. So I'm gonna do the same thing. I'm gonna take the x's and subtract them. So if I take x2 is 4, and I'm subtracting x1, which is -3. So 4 minus -3 really makes +3. I'm going to do the same thing with the y's. I'm going to take 2. I'm going to -5. 4 plus 3 is 7. 7 to the power of 2. 7 times 7 is 49. 2 minus 5 is -3. -3 to the power of 2 is -3 times -3. You're always going to bring down a positive number. So this is +9 I'm bringing down. What a coinkydink. In this case, I have square root of 58. And that is the same as this. So it's around 7.6. So what kind of triangle would this be? Isosceles. Okay, so take a second, plot your points for example 3. Okay, so once you have your triangle, there's probably one side because you have a picture of it, which is nice. Which side do we not need to find the length of? JK. JK is obviously the longest. So it's either going to be a scalene triangle or it's going to be an isosceles triangle. So this time we're only going to find the lengths of the other two. Yeah, the other two sides. So the good thing about having a graph is visually your eyes are not going to lie to you. A graph cannot lie unless like it's scaled weird, which is not going to be. So I'm not going to find the length of KJ. I'm just going to do KL and LJ. So let's do, I guess, L or KL first. Or LK, doesn't matter. The coordinate point for K is -4, 9. L is -3, -1. You could rewrite it if you want to. I'm not going to because it's right there. So I'm just going to plug in my numbers. I'm going to use the middle coordinate and the last coordinate. I'm subtracting my x's and I'm subtracting my y's. So if I do -3, I'm minusing -4. I'm subtracting a negative, so it's going to make a plus. So I have -3 plus 4 to the power of 2. And then do the same thing with the y's. -1 minus 9 to the power of 2. And then simplify PEMDAS for life. -3 plus 4 is 1. 1 to the power of 2 or 1 squared is still just 1. Then I have -1 minus 9. -1 minus 9 is -10. What is -10 to the power of 2? What's -10 times -10? 100. If I add them together, I get 101. And then I can shift in square roots. So this is just over 10. It's like 10.04. So KL is 10.04. So now LJ will determine, is this an equilateral, not an equilateral, except when not equilateral. Is it an isosceles or it is a scalene? So now let's use coordinate points L and J. So today is not really hard. It's a little time consuming. It's a kind of obnoxious, but it's not terrible. So using L and J, remember it doesn't matter which one goes first, which one goes second, as long as your X's are subtracting and your Y's are subtracting, it does not matter. So I'm going to write it as -3 minus 7, just because like L is written second. So -3 minus 7. If you write it the opposite way, you will get the same exact answer. So -3 minus 7, and then I'm going to subtract my Y's. -1 minus -2. Because it's -1 minus -2, it becomes +2, because when you're subtracting a negative, it adds. -3 minus 7 is -10. What is -10 to the power of 2? 100. -1 plus 2 is 1. 1 squared is just 1. So I get 101 again. So what does that mean? It is an isosceles again. Okay.